Okay, we'll talk today about capacitors and inductors when connecting to circuits. So capacitors and inductors in DC circuits. So we know that a capacitor in a DC circuit is an open circuit. Alaykum salam. An open circuit. So we have a voltage, but we don't have a current. So I here is equal to 0, but we have a voltage. I equal to 0. While if we have an inductor L, then the voltage here is equal to 0, and it is a short circuit. So we have a current, here we have a short circuit, but the voltage is 0. So we treat them that way. When we have a capacitor, then it's an open circuit, there's no current, but there's a voltage. When we have an inductor, then there's a short circuit, so we have a current, but there's no voltage. Let's have an example. Let's assume that we have a resistor here, we have a coil here, we have another resistor here, we have a resistor here, and let's have a capacitor here. Let's give it 20 ohms here, or 30 ohms, and 60 ohms, and let's have here 50 ohms. We assume we have here 100 millihenry, and here, let's say 500 microfarad. We have a voltage source here of 200 volts. So how we treat the circuit? We have one capacitor, one inductor. The inductor is a short circuit and the capacitor is an open circuit. So let's do it. So find the energy stored in the capacitor and in the inductor. Fine. So first what we do, we redraw the circuit, but we remove the inductor and we remove the capacitor. Removing the inductor, we make a short circuit. So what we will do, we keep the resistance 30 ohms. We keep the other resistance 60 ohms. We keep this resistance 50 ohms, and we have here 200 volts. So we have it this way. Now we have an inductor here, we make a short circuit for it. This is a short circuit. But we have IL here. And we have a capacitor here, so we make it an open circuit. So we have a short circuit, we have an open circuit here. And what we have here is a voltage C. Okay? So we see the 30 and 60, we can replace them with 30 parallel with 60 will give you 20 ohms. And series with the 50 ohms. Okay? And we have the voltage source here. 200 volts. So, what we have, a total resistance here of 20 plus 50, that's 70 ohms. Okay? Supplied by a voltage source plus minus 200 volts. So this is our total. So we have a total resistance of 70 ohms. Now we can calculate this current. I supply. So what is the value of this supply voltage? Let me draw it here. So I supply is equal 200 divided by 70 is equal 20 divided by 7 ampere. So what we have, our total equal 70 ohms, a voltage supply of plus minus 200 volts will give us a current I supply equal 20 over 7 amps. Now we go back to the circuit. What we have here, I supply equal 20 over 7. This is the same current I supply equal 20 divided by 7. And this will be the same current I supply equal 20 divided by 7. Okay? Now this current will be distributed among both resistors, the 30 ohms and the 60 ohms. So what we want is the current IL in the coil. So IL, we can use the current divider rule. So we multiply IS supply times the other resistance. We want the 30 ohms, the current in the 30 ohms resistance, so we use 60 divided by 60 plus 30. So this will be 20 over 7 times 60 divided by 90. Will give you 2 times 6 times 100 divided by 7 times 90. So this will go, well, okay, 9, 3, here 2, it will be 40 divided by 21 amps. We can also find the current in the 60 ohms resistance. Let's call it I2. So I2 is equal 30 divided by 60 plus 30 times IS. So this will be 30 divided by 90 times IS, which is what? 20 divided by 7. So this will be 20 divided by 3 times 7. So it will be 3 here. You get 1 here, you get 3 here. That's correct. 20 divided by 21 ampere. If you add this and this, you will get 60. Note that IL plus I2, it should give you supply current, which is 40 divided by 21 plus 20 divided by 21 will give you 60 divided by 21. It will be 20 divided by 7, which is equal. This is equal IS, just to make sure. Okay. Now we can find the voltage VC. What is VC? VC, as you see it here, is I2 times 60. So 60 ohms times I2. So it will be 60 times 20 divided by 21. So this will be 7, and here will be 20 times 20, it will be 400 divided by 7. So that's the voltage VC. So now we have VC equal 400 divided by 7, and we have the current in the inductor, which is IL which is 40 divided by 21. That's what we need. The current in the inductor and the voltage in the capacitor. Okay? So the energy stored in the capacitor is basically half C V squared. Half the value of C, we go back to the original circuit, is 500 microfarad. So times 500 microfarad, so we multiply by 10 to the minus to convert it to farads, times the voltage we have calculated, 400 over 7 squared. And will give you the energy in joules. Okay? The energy in the inductor is half L squared. So if we go back to the original circuit, what we have, the inductance is 100 millihenry. So it will be half times 100 times 10 to the minus 3 millihenry. You remember 1 Henry is 1000 millihenry. So times the current IL, the current in the inductor here, this is IL, it's the same IL here. And IL we have calculated 40 divided by 21. So times 40 divided by 21, the squared will give you joules. Okay? So we end up this short video. Just go to back to it. When we have capacitors, we treat them as an open circuit. Capacitor is an open circuit. Remember, in open circuit, we don't have a current. The current is zero, but we have a voltage. We have to calculate. So in a capacitor, in a DC circuit, we need to determine the voltage across the two plates, across the capacitor. So if we know that voltage, we can calculate the charge, we can calculate the energy, and so on. If we have an inductor, the inductor is treated as a short circuit. A short circuit will have a current, but no voltage. The voltage is zero. So we applied that to this circuit. Okay? We treat it that way. We remove the inductor, but we make a short circuit. We remove the capacitor, but we make an open circuit. So what we need to know is the current in the inductor, which is IL, which is I in the short circuit, the current in the short circuit, and we need to calculate the open circuit voltage, which is the voltage. This VC is the same as plus minus VC here. Once we do that, then everything is just mechanical. So here we found VC, we found IL, we can calculate omega C, and we can calculate also, if we want, we can calculate the charge, Q, okay, QC, which is equal C times VC. C is equal to 500 microfarad times 10 to the minus 6 times VC, which is 400 divided by 7. It will give you a charge in coulomb. Okay? So that would be the charge in coulombs. Similarly, we can calculate the flux in the inductor, which is L times IL. L is 100 times 10 to the minus 3. That would be the inductors in henries. We multiply it by the current, which is IL 40 divided by 21. And it will give you the units of flux in Webers. Okay, so this is equal flux, magnetic flux, in the coil. Okay, so this is the way how, no matter how the circuit is complicated, always you can follow this basic rules to determine whether charge, fluxes, energy stored, and so on. So our next video clip will be about, we'll go to the theorems, Thevenin's, superposition, and so on, okay? So I'll talk to you later. Thank you.